Okay, for my project today, it'll be discussing using the SAMR model in the classroom. The SAMR model by Ruben Bandura is the substitution, augmentation, modification, redefinition of tools in the classroom using technology. I'm excited to kind of walk through this. What I did here was I took a unit plan using CPM math. The unit plan is finding the area of trapezoids, triangles, and parallelograms, and I implemented the SAMR model in each of these elements using the CC1 or Core Connection Course 1 for sixth grade students. Um, in this lesson, it begins with rearranging areas. So this lesson is relatively specific in the sense that it's given a complicated figure. Students will divide it into pieces and then convert the pieces into a rectangle so that the area can be calculated much more easily. Students ideally then will develop an idea of a sub-problem and see that problems in most cases have multiple solution paths. So in the CPM, administration of this lesson does not really include any additional technology, so I wanted to start with substitution. In this case, students will be using or taking notes on their iPads using the application Notability, which is a terrific app for doing this. Students will then access their lesson via their online ebook. So this lesson in CPM can be implemented via ebook. Um, from an augmentation standpoint, students can have the ability to participate in interactive lessons using Desmos. Desmos is a really cool functionality, and I've used in a couple other elements here we'll talk about. But students are then able to use the interactive manipulatives to cut or ideally divide those shapes up, and then can try and turn them back into those initial rectangles. For modification, as the students are working through this lesson, the thought process here is the teacher can then pace them or then allow them to work independently. So if we have them either individually or in small groups of the iPads, it would allow them to do some of these unique, really unique implementing tools. The students can then see other students' responses, and the teacher then can project the specific students' responses, again, mirroring on the iPad. For redefinition, students are able to interact with each other by then responding to the text and posting the responses online, again, via Desmos. The other option here is you could hold an online discussion with students who are participating from other classes. In this situation, there'd be other sections in most cases that are teaching the same lesson at the same time. So it might be kind of cool to do an online chat where you could have obviously monitored, but you can track students as they're working across those different um, either, well, in this case, different grade levels or different classrooms. The teacher is then able to see all the students' responses. That's the best part about this. So they can see them in real time and then go through and look for mixed connections and then give them that instant feedback. So that redefinition piece could be critical. The second element of this lesson is area of a parallelogram. Here's where students will work in the composite shapes and a technology tool to decompose shapes into small rectangles, and then if it's possible, then recompose them into that single rectangle in order to find the overall area. Students will then also develop the area formula for a parallelogram. So in this case, I used substitution, the SAMR method, for students to be accessing their lesson again through the online ebook. But then students will be required again to take notes using Notability, so trying to get them in that cadence substitution. The reason I use Notability is because it allows students to have multiple tools on hand. So there's highlighting functionality, there's a circling, you can have perfect shapes, you can clone text like hot text on objects to save time instead of having to go through and write it on paper, and then collect all that paper. Students will then submit their completed notes and lesson activity via Schoology to be graded. Schoology is a great tool to be able to grade in real time. From a modification standpoint, this is where students could then use the e-tools throughout the lesson to manipulate those shapes. And the thought process here is we can try and, using Desmos, we can cut those shapes to rearrange them into pieces or form rectangles. And then once students complete the task, that e-tool will save their work so that they could share it or compare it in their small groups or with other students. That's a really cool functionality of that. For redefinition, once students have finished that lesson task, they'll be asked to create a video. Of those you can either use education, screencast-o-matic, or given the iPads and their memory capacity, be able to go through and record on their iPads to see how they turn those shapes into rectangles and how it relates to actually finding the area of those rectangles. The thought process here is it's going to reinforce the learning because asking to reiterate, to go through reiterate what they had done and then relate the shapes to rectangles to find that area. So the other cool part of this is those videos can be done independently or as a group, and it can be shared between the classes in this case, or right back with the teacher for grading. The last lesson in this component was the area of triangles. So in this case, this lesson summary, students will recognize that a triangle can be duplicated to create a triangle or a parallelogram, and they'll use that relationship to develop a formula for the area of that triangle. Substitution here, we're going back to the ebook again, trying to make it synthesized with an ebook so it's all in one place. Students could then open a resource on their iPad and then copy it right back to Notability so that they'll be able to actually manipulate or draw on it and then highlight whatever parts of that they might find would help them find the area. And then students will take their notes again using Notability for measure consistency. Augmentation here, this is where students will then outline those triangles in Notability and then try and clone that outline to be able to produce a copy of the triangle. So then students will take their clone triangles, then you can rotate them, you can move them, or you can flip them if you want, you can move them, the original triangle to make a rectangle or parallelogram. It's really cool, the manipulation you can do. And then for modification in this case, obviously prior to coming to class, students will have been assigned a question prompt. So, what do you think? How do you think we might find the area of a triangle, or how might we relate it to a rectangle or parallelogram? Almost like it as a tutorial step. And then students will be able to be expected to go in a Flipgrid, and they can respond to those answers or record those answers in those questions. The teacher ideally can then view these responses and then obviously go through and modify that lesson as they see fit. Um, for redefinition, we're looking here where students will then have an opportunity to choose one or two triangles, and they can take screenshots of that process. Again, of cloning it, and then if you're rotating it and moving it around, or even just you can flip that triangle to turn it back into a rectangle or into a parallelogram. And then ideally, students create the collage of those pictures, and then they can create, a video collage where it moves in real time, and they can walk them through the steps they took to turn that triangle to get to the rectangle. Ideally, then students will have a written or ideally possibly a verbal description of how this relates to finding the area of the triangle using video, obviously, and then finding the formula for the area of the triangle. So the area of trapezoids, this lesson 5.34, this is the last element in this process here. This lesson summary is where students will be asked to go through and develop strategies for finding the area of the trapezoids. And then we wanted them to apply those strategies for finding the area to find the area of complex shapes. So they're taking kind of a two-step or multi-step process. For the SAMR method here, students will then take, again, using Notability, take the notes in classroom direct instruction. And then from there, the students will access the lesson through their online ebook. For augmentation, we'll ask students to go through and use an online e-tool to work through with those shapes, similar to what we saw in the previous one. And then the teacher will airplay several students' work. Airplay is really cool because you can do these pieces in real time, and then you can actually kind of bounce from student to student to try and keep that engagement high. For modifications, this is where I want to make sure we change an element to this. So student will participate in Schoology discussion at the end of class. So you can create like a third discussion in there where students could participate, and then they'll be asked to describe how to find the areas of a trapezoid based on their classwork for that particular day. Students will also be asked to manipulate the shapes using that e-tool and then try to decompose the shape, then move those parts around to turn the trapezoid into a parallelogram or into a rectangle, that two-step process we talked about earlier. For redefinition, this is where we want them to show representation of this concept. We'll ask them to go online and find some images that are close to of that. So using Google Images, or even take a picture of an object in the classroom that has that trapezoid. Then we'll take that picture and put it into a drawing app, or even just Educreations can do this, and then we'll ask them they should try and show how to compose or cut that up, that trapezoid in there to cut it up, and then rearrange those pieces into a rectangle or a parallelogram. So you're asking them to not only find that, but also then decompose that and show how that would turn back into a rectangle. And then to take it a step further for higher level understanding components, this is where they would create an animated video or slideshow. Ideally, you could use some elements, possibly Powtoons would work here, where you could go through and use an animated video or slideshow where it shows their work and the steps follow to complete the task. That way they can share that out with their classmates and online or with parents. That is the entire process there, me walking through the SAMR process with this lesson through the CPM math. I hope you enjoyed it. Thank you.